The eighth cranial nerve, or auditory nerve, originates in the caudal region of the pons near the medulla oblongata and innervates regions of the inner ear. This nerve is a sensory nerve and does not have control over any muscles. There are two main branches to this nerve. The acoustic branch brings information from the cochlea to the spiral ganglion, a collection of nerve cells stimulated by the sense of hearing. Through the internal auditory meatus, a portal in the temporal bone where the acoustic branch finally joins the vestibular branch of the nerve. The vestibular branch of the auditory nerve brings information from the vestibular ganglion located in the internal auditory meatus to the pons. From the pons, information is brought to two different regions, the nuclei of the pons and medulla and the floconodular lobe of the cerebellum, which is responsible for eye movement as well as body orientation when walking. From the nuclei of the pons and medulla, information is brought to the vestibular nuclei, spinal cord, cerebellum, thalamus, and cerebral cortex.
The primary function of the cochlear nerve of the eighth cranial nerve is to transmit sound information from the inner ear to the brain. The vestibulocochlear nerve arises from the ventral and dorsal cochlear nuclei, which is situated in the inferior cerebellar peduncle. You can hear all this information right now because your cochlea is transmitting sounds via short dendrites to the spiral ganglion. The spiral ganglion is made up of bipolar cells whose axons project through the internal auditory meatus, where the nerve joins the vestibular branch of the eighth cranial nerve. The inner hair cells of the organ of Corti are responsible for activating afferent receptors in response to the vibrations of the basilar membrane within the cochlea. Vibrations simulate the delicate nerve hair cell fibers as impulses or signals. The cochlear nerve then transmits these signals to the brain, where they are interpreted as understandable sound.
In addition to its auditory function, cranial nerve 8's vestibular segment transmits information from the vestibular mechanism of the inner ear, which is critical for balance and movement. That everyone is sitting comfortably in their chairs without listing and falling to the floor is thanks in part to this nerve. One might say this is where you feel gravity. The primary role of the vestibular nerve is to transform vestibular information related to balance into a personalized frame of reference identifying the position of the head in relation to the body. As with the acoustic branch, vestibular nerve impulses encoding motion and position originate in the hairs within the fluid-filled cavities of the inner ear. These cavities, the semicircular canals, utricle and saccule, collectively the labyrinth, are positioned so that any change or rotation is uniquely codified. The nerve then transmits information concerning acceleration and position in space to the bipolar cells of the vestibular ganglion within the internal auditory meatus. From there, the nerve impulse travels until it synapses in the nuclei of the pons and medulla. The vestibular nuclei project from the pons and the medulla to many relevant locations: the cerebellum, the spinal cord, your extraocular nuclei, your parietal cortex for spatial orientation, the nucleus solitarius and vagal nucleus relating to nausea and vomiting respectively, and to your reticular formation regulating pallor.
Factors that can cause damage to the vestibulocochlear nerve are head injuries that result in skull fracture, damage to the temporal bone, ear infections that cause damage to the sensory nerve endings of the vestibulocochlear nerve, which are the hair cells. Some of these ear infections are otitis media, which is a middle ear infection, vestibular neuronitis, which is an infection that inflames the vestibular portion of the vestibulocochlear nerve. In kids, some factors can be mumps, measles, or chickenpox. When the nerve is damaged, the individual's ability to hear or to maintain equilibrium can be compromised. Unilateral damage to the vestibulocochlear nerve can result in impairment or hearing loss in one ear, tinnitus, which is ringing or buzzing in the ear, and or vertigo, which is dizziness and loss of balance.
Bilateral damage to the vestibulocochlear nerve will result in loss of localization of sound in space, complete deafness, dizziness, nausea, loss of balance, and or nystagmus, which is a rapid involuntary movement of the eyes.